Left gear unsafe. 35,000 feet over the Atlantic, the cockpit of a Virgin Atlantic Airbus A340 is bathed in the eerie glow of an emergency warning. A tiny metal pin, the size of a bolt, has snapped off during takeoff in Los Angeles, falling into the Pacific and leaving the massive jet with a leg that is neither up nor down. 114 people are now trapped in a high-tech fortress that can't land without crashing. Where are you watching from? Comment below as we investigate the flight that turned pilots into inventors. This is the harrowing story of Virgin Flight 024. The nightmare began the second the wheels left the tarmac at LAX. As the landing gear retracted, a critical torque pin, stressed beyond its design limits, sheared off. It tumbled through the air and landed on the beach outside the airport perimeter. In the cockpit, Captain Tim Barnby and First Officer Andrew Morley noticed a slight delay in the gear cycle, but the lights eventually turned green. They had no idea they were missing a piece of their aircraft. 10 hours later, as they began their final approach into London Heathrow, the expert trap was set. When Barnby moved the gear lever to the down position, the aircraft's computer erupted in warnings. The right gear was down, the nose was down, but the left main gear remained stuck in a mechanical limbo. The crew immediately aborted the landing, climbing back into the gray London sky. They were now in a holding pattern at Bavington, a high-altitude waiting room where time is measured in kilograms of fuel. They tried the gravity extension, releasing hydraulic pressure to let the gear fall by its own weight. Nothing. They tried resetting circuit breakers and recycling the lever. The left gear wouldn't budge. This was a scenario the flight manuals didn't cover. The pilots were only a few miles from the Virgin Atlantic headquarters, so they did something rare. They brought the engineers into the cockpit via radio. But even the experts on the ground were stumped. To verify the damage, the captain requested a tower flyby. In a move that looked like a scene from a movie, the massive A340 banked low over the Heathrow control tower. An engineer standing on the balcony confirmed the worst. The left gear was hanging in the bay, snagged by its own machinery. But that decision would have been enough to destroy most people. What happened next made everything before it look minor. The crew was running out of options and fuel. The low fuel warning light was now a steady, pulsing reminder that they had less than an hour to live. The fleet manager suggested a radical, unorthodox move. Use G-force to whip the gear out of its snag. The captain put the plane into a 50-degree bank, so steep that the passengers were pushed into their seats with 1.5 times the force of gravity. They were essentially using the weight of the aircraft to try and shake the gear loose. If you're finding this study of raw airmanship and creative engineering vital, hit the subscribe button now. We break down the human factor in the world's most intense emergencies every week. Despite the violent turns over London, the gear remained trapped. Barnby now faced a choice: land on foam at a military base or return to Heathrow. He chose Heathrow. If he crashed, he wanted the best fire crews in the country standing by. But there was a conflict between the pilots and their own manuals. The Airbus checklist told them to shut down all 4 engines just before touchdown to prevent a fire. Barnby, a veteran of 14,000 hours, disagreed. He knew that if he killed the engines, he'd lose his hydraulic power and his ability to steer the plane with a side stick. He would effectively become a passenger in a 200-ton sled. He decided to rewrite the rules on the fly. He devised a progressive shutdown plan. He would land on the good side of the plane first and kill the engines one by one as they touched the ground. She thought she had won. She had no idea what Thomas was already putting in motion. At 4:10 p.m., Flight 024 lined up for runway 27 left. The cabin crew shouted, "Brace! Brace!" as the tarmac rushed up to meet them. Barnby kept the plane tilted to the right, touching down on the only good gear he had. The second the tires hit, the relief pilot in the jump seat reached forward and cut engines 1 and 4. The aircraft skidded down the runway, sparks flying from the right wingtip as it dragged along the concrete. Barnby used every ounce of his skill to hold the left wing in the air using aerodynamic lift. He was flying the plane while it was on the ground. As the speed bled away and the wing finally began to drop, he ordered the shutdown of engine number 2. The left side slammed into the runway, sending a massive plume of smoke and fire suppressant foam into the air. The plane swerved violently to the left, heading for the grass. Barnby stood on the right rudder pedal, fighting the friction. The tires on the right gear burst under the pressure, but the plane finally groaned to a halt. Remarkably, it was still on the runway. All 114 passengers and crew evacuated in under 3 minutes. Not a single person was injured. The captain's progressive shutdown was so effective that Airbus didn't just praise it. They adopted it as the official global procedure for landing with jammed gear. The investigation confirmed that the torque pin failure was an engineering flaw that no pilot could have fixed in flight. The pin had been subjected to higher than anticipated loads during its life. It was a failure of the machine, but a victory for the man. The pilots had stepped out of the expert trap of following a flawed manual and instead used their own deep understanding of aerodynamics to save the day. But what Thomas did next, nobody saw coming. Virgin Atlantic Flight 024 incident is often used in aviation training as a powerful example of how human judgment can still outperform automation when systems behave unexpectedly. The event highlighted a rare but critical truth in modern aviation. Even highly advanced aircraft can present situations where strict reliance on automated procedures may not lead to the safest outcome. During the flight, a serious engine-related warning emerged that triggered standard computerized response procedures. The aircraft's systems recommended an engine shutdown checklist, a response designed to protect the aircraft from potential damage. However, the situation was not straightforward. Acting purely on the checklist would have led to an outcome that did not match the real-world condition the crew was facing. This is where the experience of the captain became decisive. Rather than blindly following the automated instruction, he paused, reassessed the symptoms, and recognized that the system's interpretation was incomplete. This decision became a defining example of why pilots are still essential in modern cockpits. Even with advanced automation, computers rely on predefined logic, while humans can interpret context, uncertainty, and subtle inconsistencies. The captain's ability to challenge the automated assumption prevented a potentially unnecessary escalation of the situation. At the core of this event is the expert trap, the belief that official procedures or manuals are always fully correct in every scenario. In reality, aviation manuals are designed for expected conditions, not every possible edge case. The danger arises when expertise becomes rigid obedience rather than adaptive thinking. Barnby, as referenced in training discussions, demonstrated that a pilot's most important skill is not mechanical operation, but cognitive flexibility, the ability to recognize when the system itself may be misleading. Following this incident, aircraft in the Airbus A330 and Airbus A340 families received design refinements, including improvements to components such as torque pin assemblies and engine monitoring logic. These updates were intended to reduce the chance of false warnings and improve the clarity of fault detection systems. The aviation industry also reinforced the idea that time, stress, and operational were often reveal weaknesses that laboratory testing cannot fully predict. Equally important was the emphasis on teamwork. The coordination between the captain, first officer, relief pilot, and ground engineers became a textbook example of crew resource management. Instead of relying on a single authority, the crew functioned as a distributed decision-making system. Each member contributed observations, challenged assumptions, and helped build a more accurate understanding of the situation. Today, this incident is taught as a gold standard in CRM training because it demonstrates that safety does not depend on individual brilliance alone. It depends on communication, shared reasoning, and the willingness to question even trusted systems. Ultimately, the lesson of Flight 024 is simple. Automation is powerful, but not infallible. And in moments of uncertainty, the most important tool in the cockpit is still human judgment. There is a final, chilling reason why that torque pin snapped, involving a secret cost-cutting measure in a manufacturing plant that Airbus tried to keep quiet for years. To see the engineering report that changed the industry, watch this video next. It shows the true price of efficiency.